Hey guys, I'm back again, and I am hoping today that we can finish up these trig word problems that we've been working on. So I printed out some fresh copies for myself so you can do some on your end and I can do them here. You're going to find these again on pages 154 and 155 in your workbook. So if you need to, just stop the video right now and go ahead and get them out of your workbook. Okay, I'm going to start. I have a cat here who can't leave me alone and is probably going to make an appearance. Okay, so we finished number 9 already. We're on problem number 10 now, which says a 75-foot building casts an 82-foot shadow. What is the angle that the sun hits the building? A 75-foot building casts an 82-foot shadow. What is the angle that the sun hits the building? So do me a favor and pause the video, pause this for just a second. Oh my goodness, while my cat gets in the way here. Pause the video and I'm going to ask you to draw what you think this looks like and then come back. Okay, welcome back. So here is what it should look like. You're going to have the ground. You're going to have a building here that is 75 feet tall. And then there is the sun that is up here somewhere that is shining down on this building, and we're getting a shadow that's cast. Let me draw this. We're getting a shadow that's cast because of the sun here. So this is probably not the best drawing I've ever done, but it's going to look something like this, where the sun is going to cast a shadow right along here. And it tells us that the shadow is 82 feet long. And it's asking what is the angle that the sun is hitting the building, which would be right here, right? That is where the sun is hitting the building. I'm going to call that X. Now, you might realize, gosh, that's not a great thing because we have a right triangle right here and our angle is not in it. But if we think about this, we've got two parallel lines right here cut by a transversal, right? So we've seen problems like this where we can find this angle somewhere in this triangle. Two parallel lines cut by a transversal. We know that corresponding angles are congruent. So this angle right here would also be X. Right, so it's asking us to find this, but it's the same as this X right here in this triangle. Okay, so then think for just a second, what trig function would you use to set this up? Again, if we strip it away to just the basics, we've got 75 here, 82 here, and this is the angle we want to find. So hopefully you said tangent. So tangent of x equals 75 over 82. All right, so get out your calculator if you have not done that already, and you're going to do tan inverse and then just 75 divided by 82. I would not do 75 divided by 82 first and get a decimal approximation. I would just put in 75 over 82. So when you do that, you should get x equals 42. I'm going to go with 42.4 degrees. It's actually 42.447, but we'll go with 42.4 degrees. All right, problem 11. It says over 2 miles, and they're talking about a horizontal distance, the road rises 300 feet in the vertical direction. What is the angle of elevation? Again, these problems are getting a little bit more obscure because you don't ever measure things like this. You've got a lot of familiarity with kites and ladders and things like this, but maybe not roads rising. But just pause for just a second, stop the video, and I want you to draw what you think this looks like. Okay, so you should have something like this. Over 2 miles of horizontal, so I'm going to say that this is the 2 miles. The road rises like this, 300 feet. Right? And it asks us for what is the angle of elevation. So again, we're asked for this angle right here. Here's the horizontal, and imagine, remember we talked about your one arm going out and the other one moving up or down. For angle of elevation, it's moving up. And so the angle is the one that's between your horizontal arm and the one that's just moved up. So we're looking for this. Right now, hopefully you've spotted a problem here already, and that is that we have two different units of measurement. First one is 300 feet and the second one is 2 miles. So you need to change one of them so that it is consistent with the other. I'm going to choose to change 2 miles into feet because if I change 300 feet into miles, I'm going to get a decimal value for that, and I'd rather not do it. So if you remember from memory work or wherever that 2 miles or 1 mile is 5,280 feet. So if we do 2 miles, we end up getting an equivalent right here of 10,560 feet. Oh, here's the cat again. Watch out, please, sir. Okay, so then think about what trig function you would use. All right, hopefully you came up with tangent of x is opposite, which is 300, over adjacent, which is 10,560. And then use your calculator. Do tan inverse of both sides. Just for sake of time, I'm not going to write the tan inverse. I'm just going to do it on my calculator. So second tan inverse of 300 divided by 10,560. And you should get 1.6. I got 1.627, but 1.6 degrees is the angle of elevation. Okay, next one on this page. A boat is sailing and spots a shipwreck 650 feet below the water. A diver jumps from the boat and swims 9,385 feet, or I'm sorry, 935 feet to reach the wreck. What is the angle of depression from the boat to the shipwreck? So again, pause the video and draw a picture here. Okay, so here's my picture. At the bottom of the ocean, here's our shipwreck. This is why I'm a math major and not an artist. All right, there's the shipwreck. We know that it is 650 feet below the surface of the water, so we're going to say this is 650 feet. And then this boat on the surface of the water has spotted this somehow. And so then a diver jumps off from that boat and he or she has to swim 935 feet. So clearly we're not directly over the shipwreck. We have to be a distance away. And so the diver is going to swim down here. And we know that this is 935 feet. And here is our triangle right here. And so it says, what is the angle of depression from the boat to the shipwreck? So again, if you remember our conversation in class, here is your arm going out horizontally, and then you're lowering this arm right here to form an angle, and that is your the angle of depression. All right, and just as it turns out, our angle of depression is in our triangle. Remember the one that we did before with the let's see, I think it was the Leaning Tower of Pisa, or no, the depression from the top of an apartment building to the fountain, where it was outside of the triangle. This time it's actually in the triangle, which is good for us. All right, so it's asking for what is that angle of depression right there. So think for just a minute about what trig function you would use. All right, so I'm going to use sine. So sine of x is 650, oops, sorry, I keep hitting the leg of the tripod here, over 935, right, opposite over hypotenuse. Then use your calculator to do sine inverse, so you get x equals, and I'm going to do sine inverse of 650 divided by 935, and I get 44.04, so I'm just going to go with 44 degrees. or you could do 44.0 degrees. You could always round to the nearest tenth. That's totally fine. Either, I'm sorry, I am rounding to the nearest tenth. You could always round to the nearest hundredth if you wanted, and then you would go up and add another decimal place there. All right, I'm going to start a new video because these take a long time to upload, so move on to the next.